Hello and welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 33, Effect of a NATM tunnel construction on slope stability using PLAXIS 2D. So in this tutorial, we intend to investigate the effect of construction of NATM tunnel on the stability of this slope. So the geometry is like this, as you can see in this figure. We have two soil layers. The bottom is clay or limestone. We are going to model this limestone using a Hoek Brown model, and also the upper soil layer we have a sandy stiff clay soil layer, and we will use a hardening soil model to model this soil in PLAXIS 2D. And we will have a tunnel which is 5 meters above the limestone layer. As you can see, we will have this shape, which is almost like a horse shoe shape. And we will have a lining, and also we will do this tunnel construction by using this method, NATM method, and in this method the tunnel is constructed using excavation. So we will have excavation in two stages. The first part of the tunnel will be excavated, and then this primary lining will be used as a support, and after that the second part of the tunnel will be excavated, and again the lining will be used as a support. So what is NATM tunnel? It is called the new Austrian tunneling method, and it is a tunnel construction technique that depends on the inherent shear strength properties of the surrounding soil to provide stability. So when excavation in this method, excavation is carried out in stages, and so after each excavation, immediate supports are applied using linings or shotcrete, rock bolts, or steel ribs to provide primary lining as a temporary support. And once the ground movements are controlled, so a secondary reinforced concrete lining is provided to support or to provide a permanent support for the stability of the tunnel. So as we can see, the calculations are finished, and we can check the safety factor at each step. So first I want to check the safety factor at initial phase when there is no tunnel excavation. And in here we can check and see the reached safety factor is about 4, which is equal 3.933. And after the first excavation, so when we have the first excavation, we can see the safety factor is decreased to 1.9. So as you can see, in initial phase it's almost about 4, and decreased to 1.95 after the first excavation. So after supporting the excavation with the first lining, we can see the safety factor is increased to 3.9, And after the final excavation, we can see again it is decreased to 1.7, and after completing the all lining as a support for the excavation, we can see the safety factor is 3.945. Also, we can check the critical failure surface at each construction phases. As you can see, this is a deformed shape at the initial phase. We click on deformation, total displacement. This is the failure surface at first, and after the first excavation, we can see the failure surface shifted to above the tunnel, and after the first lining, we can see again the failure surface shifted to here, and after the final excavation, again this is the most critical failure surface above the tunnel. After construction of the tunnel, final construction, you can see again this is the most critical failure surface. Also, we can click on second or final lining, and we can check the forces in the tunnel. To do this, we click on the last construction phase of the tunnel, second or final lining, and we click on this option, and we will click on plate and click on view. So as you can see, this is a deformation of this lining at the final phase. If I want to check the axial forces, as you can see, this is the maximum and minimum axial force, and also the shear force, and also the bending moment, as you can see. So this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.